This is the second part of the rational expression video. In this we discuss how to simplify various type of rational expressions. So we start with simplifying rational expressions. To simplify a rational expression, what we do is we cancel the common factors. So we can say simplify by cancelling, simplify by cancelling the common factors. So cancel the common factors. So that's what we do. So let's look at an example. So actually we can write it like this. So we can say if we have A times C divided by B times C. So C is the common factor. So we can cancel it. So once you cancel it, you're going to get the expression A over B. So that is the simple argument. So we can look at an example. Let's say we have x squared minus x minus 12 divided by x squared minus 16, and we know how to factor these kind of expressions in the previous video. So we're going to factor the top. So the factors of the top is you can see x minus 4 and x plus 3, x minus 4 and x plus 3. And from the bottom, that's the difference of squares formula, because 16 is 4 squared. So you can write this one as x minus 4 and x plus 4 because of the difference of squares formula. If you are not familiar with how to find factors, please look at the video about factoring polynomials, and you can find the link in the description. So now since this is the common factor, we're going to cancel it out. So we're going to get the rest. So x plus 3 over x plus 4. It's very simple, and you can see that we cannot simplify this further than that. And this one is valid only when x not equal to 4. So the assumption here is c cannot be 0. So that means in this case x cannot be 4. Okay, so that's how you simplify these rational expression. So you can try this as a problem. So 3x squared minus x minus 2 divided by 5 minus 4x minus x squared. So you can try this as a practice problem. So let's look at the next type. So next we can talk about algebra of rational expressions. Algebra of rational expressions. So the first and the easiest is the multiplication. So we're going to start with that. So the multiplication. Multiplication. So that means when you have like a times a over b times c over d, so what we can do is we can cancel the common factors if possible and leave the rest as a product or a quotient. So what we're going to do, cancel common factors, cancel common factors, cancel common factors if possible, and leave the rest as a product or quotient. Leave the rest as a product or quotient, depending on what we have. So we're going to cancel common factors and leave the rest as a product or quotient. So let's look at an example. So we can do this one. So we have 2x squared plus x minus 6 divided by x squared plus 4x minus 5 times x cubed minus 3x squared plus 2x divided by 4x squared minus 6x. So what we're going to do, the first step is factor these. So we're going to factor the first one. So the two factors are 2x minus 3 times x plus 2 divided by this one gonna factor x plus 5 times x minus 1. That's the first one. Second one, you can see that x is a common factor. You're gonna pull the x out. Once you take the x out, you're gonna see that you're gonna get quadratic. So which has the two factors x minus 2 and x minus 1. The bottom also x is a factor. So once you take x out, you can see that you're gonna get and also 2 is a factor. So you can 2x out, then you can see that you're gonna get 2x minus 3. So you're gonna get 2x minus 3. Now what we're gonna do is you're gonna cancel common factors. So you can see that 2x minus 3 cancels with 2x minus 3. And then you can also see that there's x minus 1. You can cancel. So I'm gonna cancel this in a different directions. Then you can see what you cancel. You're gonna cancel like that. So that's like a kind of good practice, like you cancel different angles. And then you can see that there are no there's x that you can cancel out. So I'm going to cancel x like this, x and x. So those are the only common factor that you can cancel. Now what we can do, we can write the rest. So from the top, you're going to get x plus 4, x plus 2 and x minus 2. So x plus 2 and x minus 2 from the top. From the bottom, you can see that you're going to get 2 times x plus 5. And this is only valid for the terms that you cancel out when they are not equal to 0. So that means x cannot be equal to 0, x cannot be equal to 1, and also x cannot be equal to 3 halves. So this is only valid when x not equal to any of those numbers. So that's how you can write the final answer. And you can distribute and write as simple expressions. That's like another option. For example, if you look at the top, you can write this one as, because of the different squares, x squared minus 4, and the bottom you can write as 2x plus 10. So that's another way to write the final answer. So any of them are correct. So that's the first type. This is the multiplication. You can see it's very simple. We factor, cancel common factors. Let's look at the next type. Next type is the division. When we have division of fractions, what we normally do is, if we have a over b divided by c over d, what we're going to do is we can write the first one as it is, and then second one we make it a multiplication and flip over. So we're going to c over d over c. So you can see that you see this change. So the division became a multiplication and flip the second fraction. So we're gonna look at this example. So we have x3 plus 8 over x squared minus 4 divided by x squared plus x minus 2 divided by 3x minus 6. So by the theory, what we can do, we can write the first one as it is, x cubed plus 8 over x squared minus 4, and then make it a division, a multiplication, and flip over. So it's going to be 3x minus 6 divided by x squared plus x minus 2. Now you can see that this is just a multiplication. That means we can use the steps that we did earlier. So this is a multiplication. Since it's a multiplication, we can just go with the factorization first. So x3 plus 8. This is a cube. So we can do that 8 means 2 to the 3. So this is sum of cubes. And we know how to factor sum of cubes using the formula. The first factor is x plus 2. And the second factor is the complicated one. So that is x squared product with opposite sign. So 2x and the square of the last term. That's how we use the formula. So we use the formula. We know that if we have a3 plus b3, which is equal to a plus b times a squared, the opposite sign and product, plus b squared. So there's no 2 here. and a similar one works for a minus b. So if you have a3 minus b3, this is a minus b, and then times, and there is this one, times, so what we have is a squared plus ab plus b squared. So we can use that's what we use for the first term, the second term. Now for the bottom, there's a different squares that we know, x minus 2, x plus 2 from the different squares, and do the same thing with the other terms. So we can factor 3 out, so it's going to be x minus 2, and then for the bottom, it's going to be x plus 2 and x minus 1. So those are all the complete factorization. If you are not familiar with how to factor things like that, you can look at the video about factoring polynomials. So we discuss all these types. Now what we're going to do, we're going to cancel common terms, one from numerator, one from denominator. So x plus 2, go with x plus 2, and then x minus 2 cancel x minus 2, and you can see that there are no more common factors. So that means we can leave the rest. So when you have common factors, if you see there are two terms in the bottom, you can cancel anyone you like. So for example, we could have also cancelled this one. So it doesn't matter which one. Okay, good. So we write the rest now. So from the top, you get 3 times x squared minus 2x plus 4. And you can see that you can factor the second term. And in the bottom, you have x plus 2 times x minus 1. You can leave in this form, or you can distribute and write the other form, or distributive form. This is up to you. And here this works only when x not equal to negative 2 or 2, because those are terms that we cancel. Okay, so that's how you do the division problems. So let's talk about adding and subtracting next. For adding and subtracting of fractions, we use a shortcut formula. So the shortcut formula is a over b plus c over d. What we can do, we're going to multiply like a cross. So we're going to multiply like a cross. That means we're going to get AD plus BC over BD. And you can see that you exactly going to get this formula if you try to take the common denominator. Because for the first one, you have to multiply by D, the top and bottom. And the second one, you have to multiply by B, the top and bottom. That's why you get AD and BC. So we have a similar one for the difference. So when you have A over B minus C over D is also equal to, you can write this one as AD minus BC over BD. So those are the two shortcut formulas. So I'm going to clean this up. So we have this. So those are two formulas. This is for the plus. So that means plus go with the plus sign, minus go with the minus sign. That means you don't need to remember both. You only need to remember one of them. So it's just a sum. Okay, so we can also add in. So you can say if it's a minus, this becomes a minus. Good. So that's the theory. So let's look at some examples. So you may also, in theory, you may also use the least common denominator. Least common denominator. Least common denominator when simplifying fractions. When simplifying fractions. So let's look at one example. So let's say we have x over x minus 2 minus 2x minus 1 divided by 3x plus 4. So this is a subtraction problem. So we can use a second version. What we're going to do is we're going to multiply like a cross. So we're going to multiply the cross multiplication. We're going to multiply these two and multiply those two. That means we can write this one as x times 3 x plus 4 minus x minus 2 times 2x minus 1 divided by x minus 2 times 3x plus 4. That's the bottom. So what we wrote is AD minus BC divided by BD. So we write AD product and then minus BC product divided by the BD. Good. Now what we can do, we can distribute the top. So if you distribute the top, you're going to get 3x squared plus 4x minus, and then you have here 2x squared minus 5x plus 2. So you can just FOIL to get this answer, and then divided by we can leave it like that, x minus 2 3x plus 4. Now if you simplify the top, you can see 3x squared minus 2x squared, so we have 3x squared minus 2x squared, that means there's going to be x squared, so we can simplify like that. And then if you look at the x terms, you have negative 5x, that means positive 5x, with 4x is going to be 9x, and then the numbers is negative 2 divided by the product in the bottom. You can either write this version or the expanded version. So you're going to get like this, and then you can see that the top you cannot factor anymore. So that means this is the simplified version of this one. So so you can try this one as an practice problem. So x over 2x minus 1 minus 1 over x plus 3. The same argument works. Actually, let's make it a positive one. So you can add them. So same argument works for the plus sign. So it's just you add them. So let's talk about the LCD method. So let's talk about the LCD method. So especially when you have more than 2 terms, you have to go use the LCD method, because the shortcut method works for 2, and then there is a shortcut method for 3, but it will be much easier to work with the LCD method. So let's look at a problem. So let's say we have 2 over x minus 1 plus 3 over x minus x plus 4 divided by x squared minus 1. And you can see x squared minus 1 has 2 factors, x minus 1 and x plus 1. So the LCD, the least common denominator, is the product of different factors. The product of different factors are x minus 1 and x plus 1. So that's the product of different factors. So this is the product of different factors. Product of different factors. So when you have product of different factors, you're going to create the LCD. Now what we're going to do is we're going to multiply each expression. So we're going to compare the denominator with the LCD. We're going to compare the denominator with the LCD and multiply by the missing terms. For example, if you look at the first one, the denominator is x minus 1. So what is missing is x and x plus 1. Those two are the missing one. So what we can do, we only multiply the numerator by the missing terms. So that's the kind of shortcut. So that means we multiply 2 by the missing ones. One is x, the other one is x plus 1. So that's what you get from the first term. The second term, x is there. So x minus 1 and x plus 1 is missing. So 3. And then x minus 1, x plus 1. So x minus 1 and x plus 1. And for the last one, you can see that we have x minus 1, x plus 1 is there. So only missing term is x. It's going to be x times x plus 4. It's already there. So that's how you get the numerator. So just multiply by the missing terms. So you just compare the denominators and look at what is missing from the LCD, and you just multiply the missing term, and then the LCD goes here. So x minus 1, x plus 1, Now what we're going to do, we're going to simplify the top. So we simply distribute, so you're going to get 2x squared plus 2x, and the next one 3 times the product, so you're going to get 3x squared minus 3. The next one is negative x squared negative 4x. The bottom is still the same, which is x. You can write this one as x squared minus 1, same thing. Now you're going to simplify. So we have, if you look at x squared terms, we get the largest power. This is x squared terms, we have 5 and minus 1, so 4. So it is 4x squared. And similarly, you're going to get 2x minus 4x is minus 2x. And the number is negative 3. And then you can see that there are no more factors. So that means we can leave it like that, because there are no common factors. If there are common factors, you have to cancel, but unfortunately there are no common factors, so we can leave it like this. Good. So you may try this as a practice problem, so it's an exercise. So try to simplify 4 over x minus x plus 5 over x squared minus 4 plus 4 over x plus 2. So you can simplify this one like this. So let's talk about the complex fractions or complicated fractions. So what are the complex fractions? So complex fractions means the numerator or denominator or both are another fraction. So it's a fraction of a fraction is called complex fractions. So we're going to see fractional expressions with, you can see another fraction with another fraction. It can be both, so it's fractions in the numerator or the denominator, or both in the numerator or denominator, or both is called a complex fractions. It's a fraction of a fraction. So for example, these are complex fractions. So these are a few examples, like 4 over x divided by, let's say, x squared minus 1. So you can say numerator is a fraction, so a fraction of fraction. And another one is, let's say, 1 over x minus 1 over y over x minus y. So this is again a fraction of a fraction. So let's discuss how to simplify things like this. Simplifying complex fractions. So let's look at the first example. So let's say we have 4 over x divided by 12 over x squared. So you can see this is a fraction addition problem. So what we normally do, as we discussed before, we write the first one as it is, and then the division, we make it a multiplication and flip over the term. So that means it's going to be x squared over 12. We have to flip over. After that, this is just a fraction multiplication problem. So you're going to cancel the common terms. So 4. So this is 3. This x cancels one of them. So that means you simply end up getting 1x divided by 3. So it's very simple. So let's look at a little complicated one. Let's say we have 1 over x minus 1 over 2 divided by x squared minus 4. So this is the major division here. That's the main division. So what we can do, as before, we can write the first one as it is. So 1 over x minus 1 over 2, and we in a parenthesis now, and then make it a division and then flip over. So flip over means, because this is the numerator in the major denominator, so it still has to be the major denominator. That means you can think of this one as so divided by 1. So that means if in a flip over, it's going to be 1 over x squared minus 4. You can see that we flip over the fraction, because we have here in the first one we have x squared minus 4 divided by 1, Now we have 1 over x squared minus 4. But you can see that x squared minus 4 is still sitting in the numerator. That's the easy way to think about. Now what we can do, we can simplify the first expression. To do that, this is like a fraction subtraction formula, so we're going to do shortcut. So with the cross multiplication, so it's going to be 1 times 2 minus 1 times x divided by the products 2x. So the shortcut times what we can do is we can factor this. So this x minus 2 times x plus 2 by the difference of squares formula. And you still do not see the common factor. So what we're going to do is we're going to flip over, we're going to pull a negative sign out. So that means you can write this one as x minus 2 now. If you pull a negative sign out, and the bottom is 2x. Here we have 1 over x minus 2 times x plus 2. Now you can see that this term get cancelled. So once you cancel that term, that's the only term you can cancel actually. So you're going to get negative sign 1 over, we have 2x here and then x plus 2. So that is the final answer for this problem. So you can try something like this. So this is an exercise problem. So let's say you have 1 over x minus 1 over 3 divided by let's say 1 over x plus 1 over 9. So let's see how you can simplify something like this. Good. So let's look at another example. As the final topic of this discussion, we can talk about how to simplify different quotients. Different quotients appear in calculus classes when you try to find the slope of tangent line. So we can talk about some basics about that. So let's say we're gonna get an expression like this. So let's say 1 over x plus h minus 1 over x divided by h. So this is a expression that appears in difference quotient problems. So the question is how to simplify this one. You can see that this is a complex fraction. So what we're gonna do is we're gonna rewrite this one as first we're gonna rewrite the numerator. So it is 1 over x plus h minus 1 over x, and then the division by h you can write as a multiplication of 1 over h. So we can rewrite it like this. And then for the first part we can use the shortcut method. So we can use the shortcut method, like for example, if we have a over b minus c over d, you can write this as ad minus bc over bd. That's a shortcut. So if you use that, so it's gonna act like a cross multiplication. So in this case, we're gonna get x, well, 1 times x minus 1 times x plus h, and then divided by. So we don't need a parenthesis here. So let's write again. So we have x minus x plus h divided by x plus h. So that's what happened to the first term times 1 over h. And then if you distribute, you can see that x and then minus x minus h over x plus h times 1 over h. And you can see that x minus x get cancelled first. So once you do that, you can see you're going to get negative at in front and h over x plus h times 1 over h. Now you can see that you can cancel h and h. So that's the second step. And then you only end up getting negative 1 over x plus h as the final simplified form. So this is how you simplify a fraction like that. So let's look at one more with a square root, because that's very common in different quotient problems. So we have x plus h square root minus square root x divided by h. So when you have square root functions, we have to treat this in a different way. So we can use a special technique called the multiply by conjugate. So we can use the multiply by conjugate method. Multiply by conjugate. So that's the technique we use. So what is the conjugate is we get a term with the opposite sign. So you see that there's a minus sign. So that means we're going to get a term with the plus sign here. That's what we call the conjugate, opposite sign. So that means we're going to multiply the top and bottom by that. So we can write this one as x plus h. So we just rewrite this minus square root x divided by h. So we're going to multiply this by a special 1. So what the 1 is the conjugate of that term. So conjugate of this term. So we're going to multiply the top and bottom by that. So that means it is x plus h minus square root x divided by h times, we write the conjugate here, which is x plus h, no change there, but we change the sign here. And then we multiply the top and bottom by that, because this is simply 1 with the exact same term. So now we're going to simplify this. You're going to simplify the top. So you can see there's a special simplification here. So it looks like we have a minus b and a plus b. Those terms are the same. So let's recall what we have. We have a, if we have a minus b times a plus b, we know that by the difference of squares formula, this is simply going to be a squared minus b squared. Or if you write with square root, you can say like this: if you have square root a minus square root b times square root a plus square root b, this you can write as a minus b. So that's much simpler for this one. So that's exactly what we're going to use. That means if you multiply the numerators, what we get is the square of the first term minus the square of the second term. divided by h times x plus h plus square root x. And then you can see that when you square root, you simply get x plus h minus x divided by h times x plus h square root plus square root x. I'm writing all these steps here. You can ignore some of the steps. And then you can see now x and x get cancelled. And after that, we're going to get h divided by h times x plus h square root plus square root x. Now what we can do is we can cancel the h term. So that's the second step. And then you simply end up getting x plus h plus square root x, and that is the complete rewriting or simplification of that expression. So you can see that h is now only in the bottom. So this is how you can simplify terms with the square root. Okay, that's about the theory about rational expressions. So now you can try this practice problem for extra knowledge.